Find y parameters for the network shown in figure. So this is a dependent source problem. Again, in the y parameters, we know that I1 and I2 are expressed in terms of V1 and V2. Okay, in y parameters, we have to apply KCL. Now, in the two-port network, I told is a box will be there. Two input variables are V1 and I1. Output side V2 and I2. And I1 is going towards the node. I2 is also going towards the node. Okay, you refer previous videos. Always you have to retain the same uh, direction of the current I2 towards the node only. Okay, I1, I2 towards the center. Okay, now expression for this is V1. This is nothing but V1 only. We are measuring with respect to ground. This is a ground. This is a V1. This is V2. This is V3. Okay. Now, what is expression for I1? Potential difference V1 minus V3 by. So, expression for I1 is V1 minus V3 by 2. So, this is equation number 1. Or you can call this one as 1. V1 by 2, V3 by 2. Equation number 1. Similarly, expression for I2. I2 is potential difference. It is moving from, it's flowing from node. This is V2 to V3. So the potential difference is V2 minus V3 by 2. V2 minus V3 by 2. So is equation number. So what is that parameter? Y parameters? I1 and I2 are expressed in terms of V1 and V2. But here V3 is there. Here also I2 is equal to expressed in terms of V1 and V2. But V3 is there. So we have to eliminate this V3 term. So the solution is apply KCL for node 3. Apply KCL at this node 3 and get expression for V3 and substitute that V3 value here. That's all. Now already this direction you have to retain same I1. This I2 also you have to retain this direction only, and they are already given. It's a diamond shape, means it's a dependent source. Its value is 3 times V2. V2 is voltage here. It is a voltage dependent current source, and they are also given current direction upwards only. Arrow mark means it is a current source, dependent current source whose value depends on this output voltage V2. So they already given I1 towards the node, I2 towards the node, this direction is also towards the node. KCL states that sum of algebraic current entering into the node is 0, or sum of the currents entering into the node is equal to sum of the currents leaving from the node. Here all the three currents I1, I2 and I3 all are entering towards the node V3. No currents are leaving. So all the currents are entering towards the node. So I1 plus I2, it is going towards the node, going towards the node, going towards the node. I1 plus I2 plus 3V. It is also current source. It is a dependent current source. Its current value depends on this V. So I1, I2 plus 3V is equal to 0. Now substitute the value of I1 and I2. Half V1, half V3, half V2, half V3. No, that you have to substitute here. V1 minus V3 by 2. I2 is V2 minus V3 by 2. And this is plus 3V is equal to 0. Now throughout you multiply it by 2. Throughout you multiply it by 2. This will give you, this 2 will get cancelled. This 2 will get cancelled. So V1 minus V3 plus V2 minus V3. If I multiply throughout by 2, this 2 and 2 will get cancelled. For this second term also 2 and 2 will get cancelled. But for this denominator 2 is not there. So if I multiply 3 into 2 becomes 6. 6 V2 is equal to 0. So this will give you V, how many V3 are there? V3, V3, 2 V3. So that I will bring it to right side. We left with V1, 1 V2 and 6 V2 is 7 V2. 2 V3 is equal to V1 plus 7 V2, and V3 is equal to, divide by 2 once again. 2 V3 is this much. So 1 V3 is divided by 2. So of V1, 7 by 2 V2. Okay. Then next, the V3 value we got. Okay. This is next equation. Okay. Now you have to substitute this V3 value. Okay, this is third equation they have written. So this is fourth equation. Substitute the value of V3 in equation number 1 and 2 where V3 term is there unwanted, and because V3 we have in terms of V1 and V2 only. So if I substitute this I1 and I2, we are going to get only in terms of V1 and V2 because V3 is expressed in terms of V1 and V2 once again. If I substitute the value of V3, I'm going to get I1 and I2 in terms of V1 and V2 only. If I substitute in equation number 1 the value of V3, that is of V3, of V3 value is this. So of into of 1 into 1 by 2 into 1 by 2 is 1 by 4 you are going to get. I will simplify this. 1 by 2 V1. This way if I multiply half into half is 1 by 4 V1. This minus into my plus is again minus 2 by 7 by 4 V. After that 7 by 4 V2 is written here because is only one V2 term is there. What about this? In half, if I subtract 1 by 4th, if I in half, if I subtract quarter, in half, if I subtract quarter, 1 quarter will get here. Okay, it is 0.5 minus 0.25. 0.5 minus 0.25 is 0.25 only. So 0.25 is nothing but 1 by 4. So here you can see current expressed in terms of V1 and V2. So this is Y11 is 1 by 4. Y12 is minus 7 by 4 minus 7 by 4. So two parameters we can easily find out. And another two, again once again we have to substitute V3 value in a second equation of V3. Again if I simplify this, we'll get I2 in terms of V1 and V2. So if I simplify this, of V2 half into half is 1 by 4 V1 minus into plus is minus 7 V2 by 4. So minus 1 by 4 V1 where it is, and 1 by 2 minus 7 by 4. So that you can do using calculator. I'll show using calculator. So we have here half minus 7 by 4. Half minus 7 by 4. So 1 divided by 2 minus, so minus means you have to right click this one, minus half minus 7 by 4. Again this is to write like this. So you have to use calculator like this. If you use old calculator, this option is not there. So only for this exam, better you practice and take this calculator for exam. In old version, it is not there. So it is minus 5 by 4. It is minus 5 by 4. So by comparing y parameter equations, I1 and I2 are expressed in terms of V1 and V2. This is 1 by minus 1 by 4 is Y21 and Y22 is minus 4 by 5. So unit is Y21 is minus 1 by 4 more. Y22 is minus 5 by 4 more. Thank you.